In a world where technology just sprints ahead, constantly refreshing, always evolving, it can feel, well, almost impossible to grasp what's really driving it all. But today, we're actually going to try. We're taking a deep dive into that engine. The B.Tech in Computer Science and Engineering program will explore its foundations, the cutting-edge fields it's spawning, and really what the future looks like if you build it on this kind of knowledge.
Exactly. And our mission here for this deep dive is really to distill the core essence, the most vital insights about this program from the material we've looked at.
Yeah.
Because it's quite something, isn't it? A B.Tech in CSE, it's not just, another degree. It's genuinely considered one of the most in-demand engineering disciplines today. It's fundamentally shaping the infrastructure of our digital lives.
Okay, so let's unpack this right from the start then. At its heart, what is a B.Tech in Computer Science and Engineering program? Like, what's its core focus? What problem is it solving for people entering tech?
You could think of it as building the foundational brain and maybe the nervous system for our digital world. It's this rigorous 4-year undergraduate program. And students learn not just how to code, which is important, of course, but maybe more importantly, why a piece of software is designed a certain way. It's about mastering let's say, the architecture of thought behind the software. It's really the difference, I think, between being just a coder and being a true engineering architect, someone ready to design, develop, and, crucially, maintain complex computer systems.
That phrase, the why behind the code, that really jumps out. It sounds like it goes way beyond just learning programming syntax.
Yeah.
It's a much broader understanding, right?
Yeah.
So when we talk about building those foundations, what core subjects are we really talking about?
Precisely. It casts a wide net, making sure students get a really robust toolkit. I mean, obviously, you'll dive deep into core programming languages, that's a given. But beyond that, you're tackling fundamental concepts like data structures and algorithms. And these aren't just, academic exercises. They're like the invisible scaffolding and the highways inside every powerful application. They determine if your favorite app runs smoothly or just crashes. Then it branches out into the nervous system of computing,
Right.
how operating systems manage everything, how computer networks connect the globe, and how databases effectively become the memory, the digital memory of our civilization. Oh, and artificial intelligence is definitely a foundational piece too, teaching machines to learn and reason.
Wow. Okay. That sounds incredibly robust, a real backbone for computing. But technology sprints ahead daily, like we said. So how does this degree make sure its graduates don't just get left behind? How does a B.Tech and CSE keep pace? How does it prepare students for what's next? Maybe for fields that, well, barely exist yet.
Yeah, and this is where it gets really exciting, I think. The curriculum has to be dynamic. It is dynamic. Students get immersed in these rapidly emerging fields. It ensures they're not just learning yesterday's tech, but are genuinely prepared for tomorrow's challenges. And what really ties these fields together, machine learning, data science, cloud computing, cybersecurity, it's not just about new gadgets or software. It's a fundamental shift towards systems that are self-optimizing, data-driven systems that inherently anticipate and solve complex problems. This program really aims to put graduates right at the vanguard of that intelligence revolution.
A powerful way to put it, the intelligence revolution.
Mhm.
Can you maybe elaborate a bit more on some of those cutting edge fields? What does data science actually mean for a student beyond just, looking at data?
Certainly. So take machine learning, for instance. It's everywhere now, right? Predictive analytics, self-driving cars. It's fundamentally about training systems to learn from data without needing explicit step-by-step programming for every single task. Then you have data science. It's this mix of statistics, computer science, and often specific domain knowledge. The goal is to unearth predictive patterns, find actionable intelligence from these, frankly, overwhelming amounts of data. It's like teaching the data to tell its own story. Cloud computing is another massive one. It frees companies, lets them access huge computing power, storage, everything over the internet. No need to own massive servers. They can scale up, scale down almost instantly, like turning on a tap. And of course, cybersecurity. Absolutely critical. It's all about protecting our digital stuff, our infrastructure from threats that are constantly evolving.
So it's definitely not just theory then. It sounds like there's a really strong practical side to all this. How significant is that really, the hands-on experience? Is it just labs or does it actually push students to tackle novel problems? Does it prepare them to do things?
Oh, it's profoundly significant. That hands-on application is a core differentiator. The program really pushes innovation, problem solving through intensive practical work. It goes way beyond just standard labs. Think projects, simulations, and often really invaluable internships where they apply learning in real-world scenarios. That practical immersion, it's vital. It bridges that gap, between classroom theory and the messy, complex demands of modern industry. It's where the theoretical why really meets the practical how. It has to.
Right, that makes perfect sense. Yeah, I can see how that practical side is just non-negotiable. So, okay, when we pull all these threads together, the rigorous fundamentals, the hands-on stuff, these emerging fields, it paints a pretty clear picture of why this degree is so sought after. But where are these graduates most in demand? What kind of impact are they making?
Well, graduates get snapped up across a truly staggering array of industries. It's quite broad. You've got the backbone, like IT services, cutting-edge software development, obviously, but also the booming fields like data analytics, the dynamic fintech sector, that blend of finance and tech. It's huge. And even crucial research and development roles across all sorts of domains. Basically, their skills are needed almost everywhere digital technology plays a role.
And what about specific job titles? What kind of roles would someone with a B.Tech and CSE typically be looking at?
The opportunities are incredibly diverse, which really reflects how broad the program itself is. Common roles, software developer, obviously building the apps and systems we use daily, data scientist, making sense of all that complex information, AI engineer, designing intelligent systems, system analyst, figuring out how technology best fits business needs, and of course, cybersecurity expert, guarding the digital gates. It really does sound like a degree designed to be resilient, to handle future shifts in technology.
Yeah, it truly does. Yeah. And when you step back and look at the bigger picture, it becomes even clearer why this program is so valuable right now.
Absolutely. And the remarkable thing, I think, is how the program's versatility, its flexibility, combined with its proven high earning potential and its undeniable global relevance. It all comes together. It really makes it stand out as a foundation for a career that isn't just stable, but genuinely future-proof. It doesn't just slot people into existing jobs. It equips them with core skills to adapt, to lead whatever the technological landscape looks like down the line.
So wrapping this up, what does this all mean for you listening? Given this emphasis we've discussed on building a strong technical foundation and really encouraging innovation and problem solving through all that hands-on work, well, this deep dive shows us that a B.Tech in CSE doesn't just prepare you for a job, it perhaps prepares you for roles in industries, tackling challenges that maybe hadn't even been fully imagined yet. So the question to ponder is, how might this kind of foundational knowledge empower the next generation? Not just to build the future, but maybe to tackle some truly complex global problems that desperately need these innovative computational solutions.